Okay, I think we're recording, and I hope you can hear me. Let's see what we got here. You should be able to hear me. Test. Yeah, you can see me. I think it's recording. Got a new microphone set up. Not sure if it's working or not. So this is the Magneto we were working on yesterday, and what I've done is disconnected the primary from the points. I've got an alligator clip to the frame. I'm going to connect that. And I'm going to get my meter here and connect this to the positive and take this to negative. Okay, just a pretty much run-of-the-mill fluke. Hope you can see this. It's pretty good light in here today. Alright, so put a drill bit. So I'll show you this in the back. Put a drill bit to the back here so I can spin it. So I got that. You should be able to see. So we're going to look and see what kind of voltage the primary circuit is producing. Now this works because I just shocked the crap out of myself. So I've got it, and you'll see as I rotate it, looks like it's putting out 2.8 volts AC. Now remember, I haven't touched the points. I have no idea if they're opening on time or not. They appear to be just sitting still, so they're just open all the time. So we're just testing the magnetic flux passing through the coil and what it's producing in the primary circuit. 2.7. Okay, so either direction it's doing that. Now, I remember telling you never connect the multimeter to the secondary. Okay, don't listen to things I say. So I'm going to try it and see what happens. I know it'll produce a spark at a spark plug. I just did that, and I'll show you that in a minute. But let's connect this back to the points. Not that it matters, but it's going to ground. So now we should get some kind of voltage in the secondary, right? Because we're inducing current into the secondary. So let me zoom in. You can see what it's gonna get here. All right, so let's see if I want to blow my meter up. I don't think I will. This meter is rated at 600 volts, and this thing's putting out right now, no capacitor, nothing, 186 volts, 200 volts. That's one direction. Let's see if it's the same in the other direction. About the same. So pretty good amount of voltage. Now let's see if we can make this. I've got this little spark plug out of my what is this out of? This is out of my motorcycle, I think. So let me back this up a little bit and disconnect this. So I'm going to go let me see what I'm doing, negative to that right there, ground, common, okay, and positive or to the core center. So can you see that? I'm going to turn this light off. Actually, let me get it focused in on this thing for you. Okay, so zoom in a little bit. Okay, so okay, focus, turn the light off, maybe it'll be easier to see the spark. Okay. See a spark? I saw a spark. It's showing up on video. I guess we'll find out later. One direction, and let's barely see a spark. I might get any closer for you or not. Focus right there. Yeah, you can see a spark on here. So, even without doing anything to this magneto, even with just turning the magnet, it's producing enough high voltage, 200 volts, that jumps this gap. So imagine if we turned that up 10 times, 200 times, 20,000 volts. Your spark will be a lot greater. So when we work on mags, what we're trying to do is enhance that voltage by make sure the timing's correct and make sure that the capacitor's in the loop. And remember, so it's not the amount of flux that's flashing through the coil that makes the voltage, it's the change in flux. That's important to know that, and make sure you understand that. It's not just that all the flux is flowing through, it's that the flux is in change, and they call it stress. So it's the maximum stress on the magnetic stress. I was doing this once a minute ago, and man, I touched here, shocked the crap out of myself. So be careful when you do this, all right? All right, so this is what, 5-minute video. Hope this helps you a little bit. I'll put this on the canvas. Adios.